This is Group 8. I'm Darren Yazzie, and my classmates on this project are Garrett Bond and Myron Jenkins. This is our Week 8 presentation on creating telemetry to enable seeing and resolving problems. Now we'll explain creating a centralized telemetry infrastructure. And in order to do so, we must design and develop our applications and environments so that they generate enough sufficient telemetry. Now, telemetry is defined as the process of recording the behavior of our systems. And in order to have telemetry, there are two major components that are needed. First off is the recording of the telemetry metrics. All DevOps organizations constantly record metrics at every layer of their applications, their environments, and their deployment pipelines. And second, we need a central platform to manage telemetry metrics. This stores metrics in advance and enables visualization, trending, sampling, alerting, and anomaly detection, and it converts logs into metrics. Now we use our telemetry information as a guide to solving issues. The image you see here is just an example of a daily work and where they succeed, fail, and the deployments are. Now we collect data at the business logic, application, and environment layers. These layers in telemetry become events, logs, and metrics. Logs should be sent to a service that is centralized, rotated, and deleted. Metrics should be gathered at all layers of the application. We use metrics in all areas, all layers of the application, and we use that to monitor how the system is behaving. And an operating system can provide metrics as well, and it can provide information on the system performance and how the hardware statistics are measuring up. Now, once we have created the telemetry infrastructure, we need to make sure that the applications can support a couple of things. We create application logging telemetry to collect check-in and deployment of software code artifacts, and it should support these 5 levels. The first level is the debug level, which logs and records all database operations, system processes, and errors. The second level is the info level, which records actions that are user-driven or system-specific. And the third level is the warning level, which warns of conditions that might lead to an error. Fourth level is the error level, which gathers info on error conditions. And the last level, of course, is the fatal level, which gives information to us that we must terminate the application. We use telemetry to guide our problem solving. Making our own markers triggers developers and operators and others so they can more quickly spot what caused the problem. Now, event counters and triggers can be installed with one line of code to count or measure a key component so that it is easily inserted. And also a widely used metrics library can be set up as a reading dashboard, as is called StatsD. Now we enable the creation of our daily production metrics. And production metrics can show anything from group stats and bills to individual items in the current project. The one-line triggers can be added often in difficult code to help solve complex problems, then removed as it starts working correctly. Possible tools used can be JMX, Codahail metrics, New Relic, App Dynamics, Dynatrace, Munin, and Collected, to name a few. We also create self-service access to telemetry and information radiators, or a metric dashboard. By making the dashboards easily customizable, it is easy to gain a snapshot of the problem, looking at whatever elements may be involved to pinpoint problems fast. Also, by storing all log data in centralized information radiators, Everybody's data is together, and it makes it easier to see how all the items work together. Self-service means that nobody else has to help find and report the data to be analyzed. Cars in the US, for example, have had this snapshot functionality in their computers back to 1996, and the display here, the image here, reflects that. We implement a continuous improvement loop on telemetry metrics. By making new triggers and metrics in our daily work, we are in the habit of making our work easy to test, track, and diagnose. And we also may choose to broadcast the information about our infrastructure just to inform our customers and demonstrate to them that we value transparency. Now, once we have created telemetry and to the entire organization, we analyze the business, application, infrastructure, and client software, inclusive of JavaScript frameworks, and mobile deployments. Now, installing proper telemetry and triggers for business analytics, application, infrastructure, and client software are huge selling points. Each purpose may need its own trigger points, some of which will overlap each other. Now, the correct layout for the viewer is also essential. Next, we implement application and business metrics. Application metrics are designed to record how long it takes to make the sale. It records user response times, and it finds faults in the application that may frustrate or cause a customer to look elsewhere. Business metrics will center on things like the time spent on a site by the user. It also focuses on the customer acquisition funnel, which is the route taken by the customer who buys items or something from the site. It will also show a business, the casual visitors, and the serious buyers. Sumo Logic is just an example of one of these applications, and it has telemetry and feedback from the user. Next, we implement the infrastructure metrics. Infrastructure level metrics show you how your system is doing, and the image here is just an example of it. They will show you your CPU load, storage and disk usage, database traffic, web server traffic, and many other things. And this is an excellent example of the application for the infrastructure metric. We also need to overlay other relevant information into our metrics. Now, the other information may vary by job and may require custom triggers for the technical people or business owners to help them understand and improve their services.